Your Microsoft 365 environment is likely suffering from a fiscal hemorrhage that most admins completely overlook. The assumption is that you need massive safety margins and static quotas to keep things running, but in reality, you're just paying for storage that sits idle while your budget disappears. Most organizations treat M365 storage like a rigid filing cabinet. The top 1% treat it like a fluid reservoir. The structural flaw isn't the data itself, but the static quotas that create dark data silos and capacity you pay for but never actually touch. If you don't shift to an elastic model, data growth will outpace your budget by 2026, and that leads to throttling paralysis. In the next 24 minutes, we are re-engineering your multi-tenant architecture to make it scale precisely with demand. You will move from being a victim of over-provisioning to an architect of efficiency. From rigid silos to the fluid reservoir model. We have to move from rigid silos to the fluid reservoir model. It starts with changing how you think about capacity. The myth of the buffer mentality. The old model is built on a specific type of fear, and specifically, it is the fear of that 2 a.m. support call where a tenant hits a hard limit and everything just stops. To avoid that call, you end up over-provisioning your resources. You add a 30% buffer to every single account because you think you are playing it safe, but in reality, you are just paying for empty space that nobody is using. The assumption is broken. Now that we've exposed the waste, let's look at the infrastructure that fixes it. We have diagnosed the fiscal leak, so now we need to build the container that actually stops it. This is where we move from a strategy of guessing to a strategy of pooling, which means we are moving away from the silo and toward the reservoir. It is a shift in the model itself. Architecting the elastic reservoir. Moving to an elastic reservoir requires a total shift in how we think about data storage across the entire Microsoft 365 fabric. In the old model, we fragmented everything. We gave every tenant its own bucket and every business unit its own drawer, but this fragmentation is exactly why you have so much idle capacity sitting around. When you split things up this way, you lose the ability to use the law of large numbers to your advantage. Some tenants are quiet while others are loud, and in a fragmented model, the quiet ones waste money while the loud ones hit performance walls. The elastic reservoir model fixes this by pulling those scattered stores into a single high-density pool. This isn't just about moving files from one place to another. It's about re-engineering the storage logic so capacity acts like a fluid resource that flows wherever it is needed in real time. To build this, we have to use Azure Elastic SAN as the foundation of our modern reservoir. Traditional storage models usually force you to buy performance and volume together, which means if you need more IOPS, you have to buy more gigabytes. If you need more gigabytes, you often end up paying for IOPS you don't even use. Azure Elastic SAN breaks that link. It allows us to use base units for our performance floor and capacity-only units to scale the volume independently. And this is a massive shift for multi-tenant architecture because it means we can set a high-performance floor for the whole organization while adding cheap bulk capacity as the total data grows. You aren't overpaying for performance on every single tenant anymore. You are buying performance once for the reservoir and scaling the volume elastically. But sharing a pool like this creates a new risk known as the noisy neighbor. In a poorly designed shared environment, one tenant's massive data ingestion can starve another tenant's search performance and slow everything down. We solve this through multi-tenant logic that creates logical isolation within the shared pool. We use resource governance policies to make sure that even though the physical capacity is shared, the performance stays predictable for everyone. This isn't about building walls to keep people out. It's about building traffic lanes to keep things moving. We use Azure SQL Hyperscale Elastic pools to manage our structured data within the same reservoir philosophy. These pools allow us to share CPU, memory, and resilient SSD cache across up to 25 different databases. Instead of each database having its own fixed resources, they all draw from the pool. So when one database is idle, its resources are immediately available for another one running a heavy report or an AI indexing job. This logic extends into the Power Platform through a shift toward entitlement-based scaling. For years, we managed environments through fixed tiers like a Tier 2 sandbox or a Tier 3 production environment. If you outgrew that tier, you faced a manual upgrade and significant downtime while the system caught up. In the Elastic Reservoir model, we move toward tenant-wide Power Platform request pools or PPR pools. We stop thinking about what a specific environment needs and start looking at the total entitlement of the entire tenant. This allows the system to auto-adjust application object server instances up to 80 per environment without you ever touching a slider. The infrastructure scales based on the actual request volume rather than a pre-purchased tier that might sit 50% empty for most of the month. The financial impact of this architectural shift is massive. Let's look at a concrete case study of a large organization managing a 50 terabyte data reservoir. Under the old static model, they were managing 10 different 50 terabyte silos and paying for 500 terabytes of provisioned space just to make sure no single unit ever hit a limit. By re-engineering for elasticity and consolidating into a single shared reservoir with automated scaling, they cut their monthly total cost of ownership by 30%. They stopped paying for the empty gaps between the silos and started paying for the actual aggregate data plus a small elastic margin that scales with them. This is the difference between owning 10 half-empty parking lots and owning one dynamic garage that adjusts its size based on the number of cars currently inside. This architecture also prepares you for the arrival of Copilot. AI indexing is a high-velocity, high-demand operation that can easily overwhelm a system. If you try to run Copilot against static, fragmented silos, you will hit performance bottlenecks or trigger massive overage charges that you didn't plan for. The Elastic Reservoir handles this by allowing the indexing service to draw from the shared performance pool of the Elastic SAN. The reservoir absorbs the spike and then releases those resources back to the pool once the indexing is complete. You aren't building a permanent expensive bridge just to handle a once-a-week traffic spike. You are building a system that grows and shrinks as the data flows. However, architecture is only the foundation. You can build the most beautiful reservoir in the world, but if the valves are stuck, the water isn't going to move. To make this work, we need an engine that handles the orchestration. We need to move away from the manual extensions and the temporary 30-day increases that define legacy administration. We need a system that watches the utilization and moves the sliders for us. We need to understand the mechanics of how Microsoft actually throttles these requests and how we can use that knowledge to our advantage. The shift from a static model to an elastic one is a shift from manual oversight to automated orchestration. It requires us to understand the token buckets, the API limits, and the trigger logic that keeps the reservoir healthy. That is the next step in our journey from waste to efficiency. We have the reservoir, and now we need the pump. We need to look at how we orchestrate this dynamic scaling to ensure the flow never stops even as the volume grows. Architecture is the foundation, but automation is the engine. Building a reservoir is a structural victory, but a structure without a heartbeat is just a monument to wasted engineering. You can have the most sophisticated Elastic SAN configuration in the world and still fail if your scaling logic depends on a human being clicking a button in a portal. Automation is the heartbeat of the system. It is the difference between a system that barely survives a spike and one that actually thrives on it. We are moving away from the era of administrative intervention and into the era of autonomous orchestration. This shift requires us to stop looking at dashboards and start writing the logic that makes those dashboards irrelevant. We are moving from the foundation to the engine. When the system can sense its own limits and adjust itself in real time, the friction of manual management disappears. This is where the true efficiency of the cloud finally pays off. The orchestration of dynamic scaling. The biggest mistake in modern M365 administration is treating a capacity crisis like a one-time event. When a tenant hits a storage limit, the standard response is to request a temporary increase. But that's a losing game. Microsoft offers these 30-day extensions to keep you from going underwater, but relying on them is like using a bucket to bail out a ship with a hole in the hull. It's a band-aid. It's reactive. In an elastic model, we replace that manual desperation with a strategy of continuous orchestration. We build a system that anticipates the wall before the tenant ever hits it. This requires a deep understanding of the token bucket architecture that now governs the Azure Resource Manager. In 2024, Microsoft moved away from instance-based limits and replaced them with a regional token bucket system for all RM operations. You should think of this as a credit system where you have a bucket that refills at a specific rate, like 25 tokens per second for read operations. Every time you poll the system for storage metrics, you consume a token, and if you burst your requests, you empty the bucket. Once it is empty, the system returns a 429 error, which means your orchestration logic must be aware of this refill rate. If your automation is too aggressive, it will throttle itself out of existence. The goal is to design scaling events that respect the bucket while ensuring the reservoir stays ahead of the data stream. You need to pace your scaling requests to match the refill rate of the region. This brings us to the trigger logic. Most admins wait for the 95% notification from Microsoft, but by the time that email hits your inbox, you are already in the danger zone. Because of the latency in reporting, you might actually be at 98% by the time you see the alert. In an Elastic Reservoir, we set our automated thresholds at 80% utilization. When the aggregate pool hits that mark, the orchestration engine fires a scaling event, which gives the system a 15% buffer to complete the expansion before the tenant ever feels the pressure. We are not just scaling, we are front-running the demand. We use Azure API Management as a buffer for these high-velocity operations because it acts as a shock absorber. It queues the scaling requests and handles the retries so that your primary storage operations never see a 429. The real challenge in multi-tenant orchestration is the API tax. When you are managing a single tenant, the limits are generous, but when you are orchestrating across 50 tenants, those limits become a cage. Every call to the Graph API or the ARM provider counts against your subscription quota. If you try to scale 10 tenants simultaneously, you will trigger a too many requests reality that can stall your entire infrastructure. To solve this, we implement a sharded orchestration pattern and distribute the scaling logic across multiple service principals. Each principal has its own bucket, and by spreading the load, we effectively multiply our request ceiling. We are not breaking the rules. We are using the architecture as it was intended to be used at scale. We also have to optimize the data we are actually pulling. If your orchestration engine is constantly scanning every site for growth, you are wasting tokens. Instead, we use delta queries and only ask the system for what has changed since the last check. This reduces the payload size and the number of API calls by up to 80%, which makes the throttling tax manageable. We also batch our requests. Instead of sending 50 individual scaling commands, we wrap them into a single batch operation where the provider supports it. This efficiency is what allows the reservoir to feel truly fluid. It ensures that the pump is always primed and ready to move resources without triggering the very defensive mechanisms designed to protect the cloud. The orchestration layer must also be aware of the throttling paralysis that happens during massive data events. When a new business unit migrates 10 terabytes of data in a single weekend, the standard scaling logic might struggle to keep up. This is where we implement predictive bursting. We look at the ingestion rate, not just the current volume. If the rate of change exceeds a certain slope, the engine triggers a double-step scaling event. It doesn't just add a terabyte, it adds 5. We are building a system that understands the momentum of data. We are moving from a world where we react to a number to a world where we respond to a trajectory. This level of orchestration creates a silent efficiency. The users never see a storage full error, and the finance team never sees a massive, unpredicted overage bill. The system just works. But even the most perfect scaling logic is dangerous if it lacks a governance backbone. If you allow the reservoir to scale infinitely without oversight, you aren't being efficient, you're just being fast at wasting money. You need a set of rules that define who gets to use the reservoir and for how long. You need to ensure that the data flowing into your pool is actually supposed to be there. This is where we move from the engine to the precision instruments of governance. We need to look at how we centralize policy while delegating the execution. We need to ensure the reservoir stays clean, even as it grows. The engine provides the power, but governance provides the direction. That is the next shift in our re-engineering process. We have built the pump, and now we need the meters and the filters. We are moving into the realm of precision governance. Even the best scaling logic fails without a governance backbone. Scaling is not an end state, it is a capability. If you scale junk, you simply end up with a bigger pile of junk. You need a filter. You need a way to distinguish between a healthy data surge and a toxic leak. That is the role of the governance backbone. Without it, your elastic reservoir becomes a bottomless pit of liability. We are moving from the volume of the pump to the precision of the meter. Speed without control is just a crash waiting to happen. We have the engine, and now we need the steering. We need to ensure that every byte in the pool belongs there. That is how you maintain a high-performance environment, and you do it through precision instruments. Governance as a precision instrument. Moving toward an elastic reservoir requires a fundamental shift in how you think about control, and that starts with the hub-and-spoke governance model. In a traditional setup, IT tries to own every single interaction. They act as the gatekeepers, they approve every site, they review every permission, they manually check every request. But here's the problem. This model breaks the moment you try to scale. It creates a level of friction that users will eventually find a way to bypass, which is exactly how Shadow IT starts. The hub-and-spoke model changes that dynamic by separating global strategy from local execution. Microsoft Purview acts as your hub. This is where you centralize your global policies, so you only have to define what highly confidential means one time. You set your retention rules for the entire tenant in a single location, but you delegate the actual execution to the spokes. The spokes are your business units. These are the people who actually understand the context of their data, and they are the ones who should be managing day-to-day membership. They decide who needs access to a specific project reservoir because they are the ones doing the work. This separation of duties is the only way to manage a multi-tenant architecture effectively. It allows the central team to focus on the guardrails, while the business units focus on the output. This is where we move away from manual checklists and implement policy as code. Instead of hoping people follow the rules, we start writing scripts that enforce those rules automatically. Consider the common problem of orphaned sites. A project ends, the team moves on to something else, but the SharePoint site just sits there. It stays active, consuming your capacity and creating a massive security risk for no reason. In our reservoir model, we use automation to identify that inactivity. If a site has no file modifications for 60 days, the system flags it and sends a message to the owner. If nobody responds, the site is archived automatically. The capacity is immediately reclaimed and returned to the shared pool without an admin ever having to lift a finger. This is not a manual task, it is a background process that keeps the reservoir lean. The same logic applies to your E5 licenses. These are expensive assets that often go to waste. If a user has an E5 seat but hasn't touched a premium feature in 90 days, the system should downgrade them. You stop the fiscal leak the moment it starts. This level of precision is mandatory if you are planning a Copilot rollout. AI does not respect your intentions. It only respects your configuration. If your reservoir is cluttered with sensitive data that has the wrong permissions, Copilot will find it. It will surface that information in a natural language query to anyone who asks. We use sensitivity-based isolation to prevent this from happening. We apply labels that act as a hard barrier for AI grounding. If a document is labeled as restricted, we configure Copilot to ignore it entirely. The AI can still help you write a memo, but it cannot pull data from those restricted files to do it. This creates a safe innovation zone. It allows your citizen developers to build agents without the risk of data leakage. You are not blocking the technology, you are simply narrowing the scope of what it is allowed to see. To make any of this work, you need a baseline. You cannot manage what you have not measured. We use a 20-point audit to establish the health of the reservoir before we start making changes. This audit covers everything from guest access settings to your external sharing policies. In the first 30 days of re-engineering, you must hit a secure score of 55%. If you are lower than that, your reservoir is effectively a swamp. You have too much dark data sitting around. This is information that has no owner and no classification, and it is the primary source of compliance drift. Drift is the slow, silent decay of your security posture. It happens when an admin makes a quick change to help a user or a permission is granted just for a day, but never actually revoked. Automated lifecycle management is the only cure for this drift. The system continuously scans the environment and compares the current state to your policy as code definitions. If it finds a discrepancy, it fixes it. It resets the permission. It reapplies the label. And it keeps the reservoir in a state of constant compliance. This level of precision changes the relationship between IT and the rest of the business. You are no longer the department of no. You are the department of safe flow. You provide a high-density, elastic resource and the automation that keeps it clean. You provide the guardrails that allow the business to move fast without breaking things. The reservoir stays healthy because the governance is baked into the code itself. It is not an afterthought. It is the very fabric of the architecture. But governance only works if the boundaries are secure. We have built a shared pool, automated the flow, and applied the filters. Now we have to ensure that the tenants cannot see each other. We have to defend the perimeter in an environment that was designed for sharing. We need to assume the environment is hostile. We need to look at how we isolate the identities. We need to ensure the tenant ID survives every single jump in the stack. That is the next stage of the deep dive. We are moving from the rules of the pool to the walls of the container. We are moving from governance to isolation. The meters are set. Now we look at the locks. We've built the system. Now we have to defend the boundaries. Efficiency is a vulnerability if it isn't armored. We have pooled the resources, automated the triggers, and metered the flow. But in a shared architecture, the greatest risk isn't the volume of data, it's the proximity of it. When you remove the physical silos, you remove the hard walls that used to protect one tenant from another. You are trading physical distance for logical depth. This means the perimeter is no longer a fence around a server. It is a cryptographic signature on a packet. We have built a high-density system, and now we have to ensure it is a high-security system. We are moving from the fluidity of the reservoir to the rigidity of the lock. We are moving from the pool to the perimeter. The system is built. Now we defend it. Tenant isolation and the hostile environment. The starting point for a multi-tenant architect is a dark one. You have to assume you are working in a hostile environment. When you design the system, you must do so with the absolute conviction that every tenant in your reservoir is actively trying to compromise every other tenant. This isn't just a cynical way of looking at the world. It is the defensive posture you are forced to take if you want to survive in a world of shared resources. In Microsoft 365, isolation isn't a single switch you flip and forget about. It is a layered defense that starts at the identity layer and doesn't stop until it reaches the storage bit. If you don't treat every single boundary as a potential breach point, your Elastic model will fail the very first time a user runs a sophisticated query. The most critical decision you will make is the choice between row-level security and container separation. Row-level security, or RLS, represents the peak of efficiency for a developer. It allows you to store data from multiple tenants in the same database table while using a tenant ID to filter the results in real time. The model is fast and it is cheap, but it is also incredibly brittle. A single error in your query logic can leak an entire table to the wrong user, which is why we shift to container separation for highly regulated data. We still use the shared Elastic pool for the underlying hardware, but we shard the infrastructure at the database level so each tenant gets its own logical container. This adds a layer of physical logical mapping that prevents a simple coding error from becoming a cross-tenant catastrophe. Identity has become your new perimeter. In the old world, we relied on firewalls to keep people out. In the reservoir model, we use Entra-ID governance as our primary source of authority. It doesn't just check a password to see if it matches, it verifies the entire context of the request to ensure the user is coming from a known device. The system checks if they are in a geography that matches their tenant's data residency requirements, and if that context doesn't match, access to the reservoir is blocked before the storage layer is even touched. This is where we implement tenant context propagation. You must ensure that the tenant ID is baked into every single layer of the stack. When a request hits your API gateway, the ID is verified, and then it is carried in the header as it moves to the compute layer. When it finally hits the storage layer, the ID is checked against the access control list of the specific container. If that chain is broken at any point, the request must fail immediately, because isolation is only as strong as its weakest handoff. This brings us to the problem of the Copilot leak. Generative AI is a master at finding connections where humans might miss them. If your isolation logic is weak, an AI agent could potentially ground its answers in data that actually belongs to a neighboring tenant. Imagine an executive in Tenant A asking for a summary of recent contract negotiations, only for the AI to pull a draft from Tenant B because they share a poorly isolated search index. This is the ultimate nightmare scenario for multi-tenant architecture. We prevent this by enforcing physical logical mapping at the search index level. We don't just filter the results after the fact, we isolate the index itself so the AI only sees data explicitly tagged with the user's validated tenant ID. This is why your Entra ID configuration is actually more important than your storage capacity. If your identity layer is soft, your reservoir is wide open. We also have to account for the noisy neighbor from a security perspective. A denial of service attack on one tenant shouldn't be allowed to paralyze the entire reservoir. We use Azure Resource Manager quotas to cap the maximum consumption per tenant. This ensures that even if one tenant's identity is compromised and used to launch a massive data egress, the damage is contained, the reservoir doesn't drain, and the neighboring tenants don't even feel a dip in their performance. You are using logical isolation to create the same effect as a physical air gap. It is a layered approach that uses Entra for logical isolation, containers for storage isolation, and ARM quotas for performance isolation. This is how you defend the boundaries of a shared system. You build a container that is as rigid as it is elastic. But isolation is only half the battle, and the other half is proving that it actually works. You need to see the results of this re-engineering in the numbers. You need to look at the fiscal impact of these choices. We have built the defense, and now we have to look at the return. We are moving from the security of the container to the success of the model. We are moving from isolation to ROI. Let's look at the actual fiscal impact of this shift. Architecture and security are the technical requirements, but the boardroom only speaks the language of capital. We have built a system that is resilient and isolated, but the ultimate validation of an elastic reservoir is its ability to transform your balance sheet. We are moving from the integrity of the container to the measurable performance of the investment. It is time to look at the numbers. Fiscal impact and the 2026 ROI. To measure the success of this re-engineering, we look at the effective savings rate, or ESR. This is the metric that separates standard IT departments from elite architects. In 2024 and 2025, cloud optimization benchmarks showed that the median compute ESR was essentially 0%. Most organizations were paying exactly what the sticker price demanded because they lacked the flexibility to optimize. However, top performers who implemented the elastic logic we have discussed achieved compute savings of 46%. They didn't do this by cutting services, but instead by eliminating the gap between what they provisioned and what they actually used. Let's quantify this for a 1,000 user institution. In a static model, you are likely over-provisioning storage and licenses by at least 30% to handle the safety margin. If your annual M365 spend is $100,000, you are effectively throwing $30,000 into a dark data silo that no one ever touches. By moving to a pooled model, you align your infrastructure costs one-to-one with revenue-generating activity. You stop paying for the what-if and start paying for the what-is. In the educational sector, where Microsoft mandated pooled storage transitions in late 2024, institutions that embraced the shift saw immediate relief from the unlimited storage traps that previously led to massive overage penalties. The real advantage of the elastic reservoir is the pay-as-you-grow model. In a static architecture, data growth is a fiscal threat. Every time your users generate more content or your AI agents index more files, you have to buy another block of capacity. It is a stair-step cost model that always keeps you over-provisioned. Elasticity turns that into a smooth slope. Your costs scale incrementally, byte by byte, request by request. By 2026, the cost of doing nothing and staying on a static architecture will manifest as a 50 to 100% year-over-year data growth tax. Without elasticity, your budget will be consumed by storage maintenance before you can even think about innovation. We also have to account for the operational excellence that comes with maturity. Re-engineering isn't a weekend project, and it follows a 3 to 4 year maturity path. In the first 6 to 12 months, you focus on consolidation by identifying the dark data and draining the silos. By year 3, you are in the optimization phase. This is where you realize the final ROI check of 30 to 60 minutes of daily time savings for every user. Because you have a governed elastic reservoir, your AI tools perform better and find information faster. They don't get stuck in the throttling paralysis of a fragmented system. You aren't just saving money on storage, but you are buying back the most expensive resource in your organization, which is human time. The fiscal impact is a virtuous cycle. The savings from storage optimization fund the advanced security tools in E5, and those security tools enable safer AI adoption. That AI adoption drives the productivity that justifies the entire M365 investment. You are moving from a victim of overprovisioning to an architect of elastic efficiency. The numbers don't just show a lower bill, but they show a more capable organization. You have successfully replaced a fiscal hemorrhage with a precision engine for growth. Now it is time to take these principles and apply them to your own environment. We have the model and the metrics, so now we need the first step on the roadmap. It's time to move from theory to implementation. The architectural theory is sound and the fiscal logic is undeniable. But a blueprint doesn't save money, and only execution does. We are shifting from the what and the why to the immediate how. You have the vision of the elastic reservoir, and now you need to turn the first valve. We are moving from the boardroom strategy to the administrator's console to begin the 90-day transformation. The static quota trap doesn't have to control your environment anymore, and you can choose to become an architect of elastic efficiency instead. Your first move is a 20-point Purview audit. You should finish this within the next 7 days to find your 3 biggest dark data reservoirs. Once you see where the waste is hiding, the consolidation process can start immediately. But here's the problem. Most people stop at the audit. If this shift in multi-tenant logic changed how you think about infrastructure, follow me, Mirko Peters, on LinkedIn. I want to hear your audit results so we can use those specific numbers to shape our next deep dive. If this breakdown helped you, leave a review. It helps more architects find the signal in the noise.